Hi everyone, it's Mr. H here. This video is all about SOHCAHTOA and the special triangles shown on the screen. And what we're going to do is we're going to see what tan of 60 degrees and cosecant of 45 degrees are exactly. This question says determine the following exactly, tan of 60 degrees and cosecant of 45 degrees. There's several levels of understanding here that we have to have. And the first one is, what do these actually apply to? Well, they always apply to 90-degree triangles. And so if I have a triangle with a 90-degree angle in it, and I'm looking for this angle right here, then this is the adjacent side to that angle. The opposite side to that angle is over here. And then the hypotenuse is the side that is opposite to the 90-degree angle. And so with that understanding of any right triangle, we can then use something called SOHCAHTOA. SOHCAHTOA. And what that gives us is it gives us the ratio of sine, cosine, and tangent. And tangent is the one we're going to want to use here. So sine of an angle is equal to the opposite over the hypotenuse, O over H. Opposite over hypotenuse. The cosine of an angle is equal to the adjacent, A over H, so adjacent over hypotenuse. And then the tan of an angle is equal to the opposite, O over the adjacent, A. And so what we're going to use for this first question is we're going to use the tangent. And so that's going to be the opposite over adjacent. Now, that's not necessarily helpful here because we don't have a triangle that has an opposite over adjacent side. But we will see in a moment that that 60 degrees corresponds to a special triangle. For part B, what I want to do here is I want to just also understand what the reciprocal identities are. So sine, the reciprocal of sine is 1 over sine, and that's given by the identity cosecant. And so cosecant of an angle, if it's the reciprocal of these. And so that's going to be hypotenuse over the opposite. And the reciprocal of cosine is secant. That's 1 over cosine, which makes the hypotenuse and the adjacent side switch. So that's going to give me hypotenuse over adjacent. And then the reciprocal of tan is cotangent, which is going to give me adjacent over hypotenuse. So those are the 6 identities that we need to be aware of, and we're going to use 2 of them here. Now what about the 60 degrees and the 45 degrees? Well, for the 60-degree angle, we need to use a special triangle. And that special triangle that we're going to use is an equilateral triangle that has all side lengths of 2. What we're going to do with that special triangle is we're going to recognize that all these angles are 60 degrees. And we're then going to take that and we're going to cut this triangle straight down in half. And if we cut that straight down in half, that means now that this angle in here is 30 degrees and we have a right triangle. Now, if the total length of the bottom was 2, that means the total length from here to there is 1. And if we use the Pythagorean theorem, we can find that the height of this triangle is the square root of 3. So what I'm going to do is I'm going to just redraw that triangle here just so we have it very clear. We have a 1 down here, a root 3 up here. It's a 90-degree triangle. This length is 2, and this is a 60-degree angle. And that's the angle that we need for what we're about to do. Because tan of 60 degrees, we have there on the right side, and that's the one that I put a box around so far. Tan of 60 is equal to the opposite over the adjacent. Well, the opposite side is root 3. So it's root 3, and the adjacent side is 1. So root 3 over 1. So then tan of 60, we can just simplify that to be root 3, and that is my final answer. So now we move on to cosecant of 45 degrees. Now for this one, we can't use the special triangle that we used before because there's no 45-degree angle in it. And so what I have to do is I have to start by drawing the second special triangle that we should know in this course. And that is, if I take a 1 by 1 square, so all the sides are length 1, and I cut that across on the diagonal, what I'm going to have is I'm going to have a right triangle clearly there, and then I'm going to have a 45-degree angle here and a 45-degree angle here. Now, if I use the Pythagorean theorem again to find the length of the hypotenuse, I end up getting root 2. And so the adjacent side to the 45-degree angle is this. The opposite side is this. And then the hypotenuse is root 2. And so if we just draw that triangle down below here, just to get a clear picture of what that looks like, we have 45-degree angles. And then we have 1, 1, root 2, and that's a 90-degree angle there. So cosecant we have here is hypotenuse over the opposite. So if it's the hypotenuse, which is root 2, over the opposite, which is 1, then that just becomes root 2 over 1, and we can simplify that to root 2. And that is our final answer for cosecant of 45 degrees. And that's all there is to it. Use the special triangles and then set up the ratios as shown. Thanks so much for watching. For more on this topic of SOHCAHTOA and how to set up the trig ratios, check out the video on the left. For more on the unit about trigonometry, check out the video on the right. Thanks so much for watching.